Hi everyone, I am Mahalakshmi from AVS department. Now we are going to talk about data structure lesson. What is data structure? The data structure is a particular way of storing and organizing data in a computer so that it can be used efficiently. Different kind of data structure are suited to different kind of applications. So storing and retrieving can be carried out on data stored in both main memory and the secondary memory. Next topic is algorithms. What is algorithms? An algorithm is a step-by-step procedure for calculations. An algorithm is an effective method expressed as a finite set of values, well-defined structure for calculating functions. The transition from one state to the next state of unnecessarily deterministic. Some algorithms incorporate random input values. And the ADT. What is ADT? We are going to talk ADT general concept. The problem solving a computer means processing data. To process your data, we need to define the data type and the operation to be performed on the data. The definition of the data type and the definition of the operation to be applied to your data in part of the idea behind an abstract data type. The user of an identity need only to know that a set of operations are available for the data type, but does not need to know how they are applied. Several simple ADDs such as the integer, real characters, pointers and so on have been implemented and are available for use in most languages. The next is data type. The data type is characterized by a set of A and various data depressions which is common to all these values. A set of these values operations which can be applied uniformly to all the languages. Why we ought to use ADT applications? Modularity. Divided programs into a small function, easy to debug and maintenance, easy to modify and group of work. Reuse. Do some operations only once, easy to change the implementation, transparent to be the programs. And the next is implementing an ADT. To implementing an ADT, you need to choose a data representations must be available to represent all necessary values of the ADT should be private. And algorithms for each of the necessary operations must be considered with the chosen representation all auxiliaries. Operations that are not in the contract should be private. Remember, once other people are use it's easy to add functionality. List of ADT. The list is an ordered sequence of data items called elements. For example, A1, A2, A3, etc. AN is a list of size. The n is the number of values. And size of an empty list is 0. A is I plus 1 successed AI. AJ plus A minus 1 processed AJ. Position of AJ is I. First element A1 called the header. The last element is AN called is the tile. Operation on list. Operations on list: make empty, print list, find kth values, insert, delete, next, previous. What is array? Array is a static data structure that represents a collection of fixed number of homogeneous data items or a set of size indexed sequence of elements all the same types. The individual elements are typically stored in constitutive memory locations. The length of the array is determined when the array is created or cannot be changed. Different type of arrays. One dimensional array. Only one index is used. Multiple dimensional array. Array is array involving more than one index. Static array. The compiler determines how memory will be allocated for the array. And then dynamic array. Memory allocation takes place during execution. Operations on list. We will consider only few operations and not all operation on list. Let us consider insert. There are two possibilities, order list and unordered list. We are going to talk about the next topic is find and search. Searching is a process of looking for a specific elements in an array. For example, discovering whether a certain score is included in a list of scores. Searching I like. Sorting is a common task in computer programming. There are many algorithms and data structures devoted to searching. The most common one is the linear search approach. Compare the given values which is element in the array. The method continues to do such until the given value matches an elements in the list of executed without a match being found. If a match is made, the linear search returns the index of the elements in the array that matches the keys. The next is singly linked list addition. Insert into a singly linked list has two specific cases. It's insert a new node before the head and then after the tail. In any other cases, new node is inserted in the middle of the list and then insert general concept. In general cases, new node is always inserted between two nodes which are already in the list. Head and tail links are not updated in the cases. We need to know two nodes, previous and next, between which we want to insert the new node. And then the next topic is singly linked list deletion. There are four cases which can occur while removing the nodes. We have the same four situations, but the order of algorithm actions is opposite. Notice that removal algorithms include the disposal of the delete nodes unnecessary in the languages with automatic garbage collection. List has only one the node. When the list has only one node that head points to the same node as the tail, the removal is quite simple. The algorithm disposes the nodes pointed by head and set both head and tail to null. Remove first. In this case, first node is removed from the list. It can be done is two-step. Updated head link to point the node. Next the head. Dispose removed head. Arrays pros and cons. Pros. Directly supported by the C programming provided random accesses. And the con is size determined at compile time and inserting and deleting elements is time consuming. Inserting item. As an example, consider the insert an item to link the new node after a given node. In a single linked list, we need to change two pointers. New node to next node, location to next node. And then the same operation and a doubly linked list required four pointers changes.